Okay, been making my notes there. And I'll be reading aloud. Great. Now, get a pencil. All right. Okay, so atoms are composed of a nucleus surrounded by electrons. The nucleus comprises protons and neutrons, known as nucleons, and that's called the nuclear model of an atom. Here we see oxygen with 8 protons and 8 electrons. All right, it is the fact that it has 8 protons in its nucleus which makes it an oxygen atom. And here we can see the properties of the particles: their charge, their mass, their relative charge, and their relative mass. The proton number is the number of protons in the nucleus, symbolized by Z. That's in a neutral atom. The number of electrons is equal to the number of protons. That makes sense. But the element's reactions and chemical behavior depend on the number of electrons. This is called nuclide notation, where we have sort of like that. Okay. Since each proton or neutron has a relative mass of approximately 1 and the electrons weigh virtually nothing, the number of nucleons is the same as the atom's relative mass. Right, isotopes. Hydrogen has deuterium and tritium. All right, we know that much. Okay. Now we'll just see how this goes. We've tried a number of things for science lately, and so now we're just going to see what happens when we just try and answer questions straightforward from the book. List the particles that make up an atom and give their relative charges and relative masses. So that would be a proton. Neutron. And an electron. And for the relative charges, you have +1, 0, and -1. of the relative masses, you have 1, 1, and 0.0005. Define the proton number and nucleon number. Okay. The proton number symbolized by Z or Z, is the number of protons. E.g. for, let's do beryllium. Z is equal to 4. The nucleon number, A, is the sum of the proton and neutron count. For the most abundant isotope of oxygen, That would be 16. Explain how the amount of carbon-14 in dead organic matter can tell scientists how old it is. Okay. Well, it's something like living things. All contain the same amount of radioactive carbon-14 taken in from the atmosphere. Once dead, the excretion and replenish cycle is over. And begins to decay. And begins to decay at a predictable rate. How do you calculate the specific charge of a particle? the specific charge of any given particle is equal to the charge of the particle divided by the mass of the particle. So okay, so it's not actually that bad, me writing this out. So what would happen now if I switch to chemistry, right? Let's just see what happens. Can't start answering questions right away, can I? Perhaps I can, because it's about the atom. Although I need to be careful about how much I actually present and show. Or would that take up an enormous amount of time? I'm just not sure if I should do just physics for months on end, and then chemistry, and then biology, or do them all concurrently, because that will just take up so much time in the day and I just don't have that much time. So I'm thinking physics would be better. Yes. And on days where I tire of that, I can alternate to chemistry. Something like that. But this was just a test run. I actually knew that page, that the material on that page. So in the future, I don't know how it will go. I need to gather more data. But this was a good test run. It's a lot better than everything else that I've done for science so far.